do it. I started to, and
Okay.
then the meeting
And
started.
this is great because this is perfect because I didn't want you to kind of get on there and get frustrated and try to do it. And if I think once I show you A, that you and your breakout group can do B and C. So what we're going to be doing is we're just doing, if you open up your textbook to page 649, and what they've done is they have given you a picture. Okay. I'm going to plug us in the document camera, so I'm not going to be able to hear you. Hopefully you'll be able to document. Yes. So the first thing that you do is this circuit is going to be for A, B, and C. Okay. So when we're looking here, we've got a 40 volt battery. Then we have resistance A. We got resistance B, Miss Sloan, and resistance C. And what they're doing is they're giving you different numbers for the resistance or the resistors that you're using. So for A, okay. So for A, we have 25 amps, 3.0 amp, and 40 amp. So the first thing that you have to do is you have to go through and do this, do your equation where you're going to do the resistance of B and C. That's these two because they're parallel. So what you're going to do is you got to do these two resistance to get a number so that you can make it into a series instead. So we're going to use the parallel that we used yesterday, which we're looking for the resistance of B and C. So you're going to do 1 over the resistance of B plus 1 over the resistance of C times -1. Well, my resistance B is 3.0. My resistance C is 40. And so what I'm going to do now is I'm going to take this and I'm going to invert it. And I'm going to make this 0.33 and this one 0.0250. And I'm going to add them together. And then I get 0.36. And I carry the 1 ohm with the -1. Once I do that, then I do this equation and I got 2.8 ohms. So what that is telling me is for this one and this one combined, I can put it here and I can make it into now a series. So now this is a series. The only thing I have to do is I'll only have to add my resistance A plus my resistance of B plus C. So what I did is I took my resistance A, which is 25, and I added what answer I got there, which was 2.8 ohms, and added them together. And so now my resistance is 27.8 ohms. Now I'm going to give you a few minutes to look that over and make sure you write that in your notes before I unplug. If you would please raise your hand on your button to let me know you're done, then I'm going to go ahead and switch off of that so I can talk to you. Thank you, Abby. Bailey raised her hand. And Jordan's raised his hand. Okay. Does this make sense to you?
Yes, ma'am.
The transfer from the 0.36 with the 1 over the change and then all that to the -1 to
Yes.
the RBC equals 2.8 ohms is where I'm kind of a little muddy.
Okay. So, do you have your calculator?
Yes, ma'am.
Okay, let's try to plug it in and see what happens. What are you getting?
Okay, that makes sense now. I
You
was
good?
just looking at the paper. I wasn't plugging it in as I went.
That's why I said, well, just listen, Bailey. Nothing wrong with that, baby. Let's sit, let's back up, let's regroup, and let's plug it in our calculator, make sure we understand. All right. So how do you feel if I'm gonna go ahead and I'm going to let y'all stay in here because there's only 3 of you. Everybody else isn't here. So what I'm gonna do is I'm going to mute myself. I'm gonna go to the bathroom, and then I'm going to have you or two as all 3 of you as a group is going to work on B and C for that problem. Does everybody understand what we're doing?
Yes, ma'am.
Yes, ma'am.
All right. I have taken my
Have y'all got your RBC yet?
I'm still working on that part.
Okay.
All right, guys, I'm back. Were y'all talking to each other? Because I didn't hear a word.
Yes, ma'am, we were.
Oh, okay, cool. Where are we at?
I've gotten my answer for B, and I was just waiting to check with everybody.
Okay.
And I've started on C.
Oh, Bailey.
I got my answer for both of them.
All right, Bailey, what did you get for 2B? I mean 1B.
I got 26.3.
Okay. And how did you get 26.3?
I said RA equals 12.0 ohms, RB equals 35.0, and RC equals 25.0. And RBC is 1 over RB plus 1 over RC and to the negative 1. And when you convert that to decimals, it's 0.03 plus 0.04 to the negative 1. And that's 0.07 to the negative 1, which is 14.3. And then I added 14.3 and 12, which is RA plus RBC, and got 26.3.
The only thing I had differently is what I got for my decimal for 35.
What did you have?
I had 0.0286.
That's what I had as well.
Okay. I just rounded mine farther up.
Yeah. Because it didn't make that big of a difference because my answer was for RBC was 14.6.
Mm-hmm.
Then my R equals was 26.6. So it's pretty close. So I think it just, like you said, it was had to do something with your rounding.
Yes, ma'am.
All right. And Jordan, did you get C?
I'm still working on C.
Okay. So tell me your progress.
All right, we'll have RA, which is 25, and I have RB, which is 3.0, and RC, which is 40. So that means we have to do 1 divided by, do 1 over RB, which is 1 divided by 3.0. We have to do the same thing for RC, so 1 divided by 40.0. Alrighty? I'm going to put those on the calculator. Once you put those in the calculator and put them together, you should get 0.355. Wait a minute, I totally did not see the RD and RE there. I knew something was up.
Which one are you doing, Jordan? We're still doing C on number 1.
I was looking at number 2. That's how my day is going right now.
Okay, so can I say, and Bailey, can you check, and Abby, can you check to make sure my math's good? So for that one, I did RB, which was 28 amps. So I did 1 over 28 plus RC, which is 1 over 12 to the negative 1, which my fractions, I mean, the decimals that I got was 0.0357 times 1 over ohms plus 0.0833, 1 over ohms, and then the negative 1, which I got 8.40 for BC. Abby, is that what you got for BC for the resistance?
Yes, ma'am.
Okay. And then I did for my, for the resistance equation, I did 15 plus 8.40 and I got 23.4. Does that sound about right to you, Abby?
Yes, ma'am.
Okay, cool.
That's
All right.
my rounding was just off again, so I got 23.3.
And it's close enough, right?
Yes, ma'am.
Yes. All right. So let's go ahead and let's look at the next problem. So on the next problem, what we're going to do now is we have a different type of series, don't we? So this time we have a 25-volt battery. We have resistance A, resistance B, resistance C, resistance D, and resistance E. So the first thing I did is I drew my resistance and I drew my schematic of it. And then what I'm going to do is I'm going to say A equals RA equals 25 ohms. And then my RB equals 3.0 ohms. My RC equals 40.0 ohms. Our RD is 15 ohms. And my RE is 18 ohms. So how is this one different than the one that we have done before?
It has 2 extra resistance.
Yep, we've
Yeah,
got
it's more resistant.
we've got 2 parallel circuits that we have to do, right? So the only thing that's different than this, and don't get like freaking out about it. So the first thing you do is you go and you look at the first parallel circuit and you do that one first, okay? Then you look at your second parallel circuit and you do your equation there, and then you just add all your series together. So what I'm going to do is I'm going to give you a couple of minutes. I'm going to do it, and I want you to try to do it. And then I'm going to share with you my answers to make sure you understand it. And then I'm going to have y'all do one together, which is B. Is everybody good?
Yes, ma'am.
All right, go ahead and work, and I'll be back with you in just a minute. All right, guys. You'll stop where you are and just look on the screen really quick. We'll go over how I did that. So like I said before, don't freak out because it looks complicated, because it's not. So now what you're going to do is you're going to do what you remember about parallel and series again, except this time you have two parallel circuits. So based on these facts here, on these numbers, the first thing I want to do is I want to do RA and RB first. Okay. Now RA is 25 ohms and RB is 3.0 ohms. So what I'm going to do is I'm going to change that to a decimal, which I get 0.0400 1 over ohm, plus my 1 over 3 is 0.33 1 over ohm to the negative 1. Once I do that, then I get 37. Now, over 1 ohm, negative 1, which gives me 2.78 ohms. So that 2.7 ohms is going to be my resistance of A and B. Now it's no longer a parallel circuit. Now it's a series. The next one I decide I'm going to do D and E. Well, my D is 15. My E is 18. So I'm going to change those out. So I'm getting 0.0667 1 ohm plus 0.0556 1 ohm to the negative 1 power. So to be able to get that, I get 0.1223 1 over 1 ohm negative 1, which gives me 8.177 ohms. Well, the hard work's done. The only thing I have to do now is I need to find what my total resistance is. To be able to do that, I'm going to take my answer that I got for RAB, which is 2.7. C is part of the series, so I'm just going to add that, which is 40. And then my D and E combination, which my answer for that one was 8.177. And I added them all up, and I got 50.9 ohms. So I'm going to give you a few minutes to look at that on the screen to make sure what you have done is working. When you get finished writing this, please raise your hand again. Thank you, Bailey. Thank you, Abby. Thank you, Jordan. All right. So was that hard?
No, ma'am.
No. Once you understood what you were doing, right? How about you, Jordan?
At first, until I went through it, I got a bit mixed up, but I'm good now.
You're good now? How about you, Abby?
Yeah, kind of.
Crystal clear, kind of. Okay. And then Grant, hey, honey, how are you today?
Hey, Miss Sloan.
I'm going to move.
Hold on. I'm in the World Market at Myrtle Beach.
Oh, you are? Cool.
Yes, I'm just checking in.
Yeah, well, that's good. What I've done is I've recorded this. Did you do the series in the combination circuits today?
I haven't done that yet. No, ma'am. I've been gone just about all day.
Listen, it's okay. So this is what's going to happen. I videotaped it. So I will put the video up for you. So that you look back at it and see. And then also I have a Tinkercad. When you get home, what you'll need to do is you'll have to hit the link and then just sign on through your Google account to get on there to play with it a little bit. Okay.
Perfect. Yes, ma'am.
Cool.
All righty.
All right. You have a good day too. Would you like me to wait and let you do the next problem, or you want to try to do it on your own and then submit it back to me and then we can talk about it tomorrow? Which one you want to do?
I think I'm going to try to do it myself. That
Okay,
way I
that's
can
cool.
go through it.
So this is what we're going to do now. We're going to stop here with this, and we're going to go on to Tinkercad. So I'm going to present my screen, and y'all are going to get on Tinkercad.
What about the one problem at the end with the other sample? There's just one that has us to do.
I did not do that one, so you don't have to do that today. We're going to do it tomorrow.
Yes, ma'am.
Okay. Thank you for, I didn't even get that far. So I got this far, but I didn't get to that page. So Bailey, I noticed you were on there when I was trying to add the lesson plan. So I'm glad I had my, the lesson on. All right, everybody go into Tinkercad. Come on. Okay, so is everybody on Tinkercad?
Miss Long,
Hey,
I'm sorry, I forgot all about it. I'm putting out straw.
I'm videotaping it again, Hayden.
See?
Are you listening to me?
Yes, ma'am, I am.
Yeah, and
I.
well, I'm recording it. So if you need to go, you can go, and then make sure you do it tonight, baby.
Yes, ma'am, I got you. I will.
I don't want you doing hay while you're doing this. Okay.
Yes, ma'am. All
So,
right.
all right. Thank you, baby. Does everybody see this screen here where I'm at?
Yes, ma'am.
Yes,
Are
ma'am.
you on that yourself, though?
I am. It just says create new designs.
Yep. Yep. All right. So what we're going to do is you're going to create a new design. Nope, not that one. Whoop. I don't think y'all want to draw something. Where I want you to go to where it says create it on the right-hand side, you should have something like a 3D design in the circuit. Or do I have to assign that to you? We're going to see. I'm trying to get to create a new circuit place. Can you get there? I tell you what, I'm going to get off of here in a minute, and I'm going to have somebody else share me your screen so I can see where y'all are.
Yes, ma'am. My screen looks exactly like yours.
Fantastic. Mine's having an issue.
This is what mine looks like at the moment.
Mm-hmm. Oh yeah, get off of there. Back up.
Oh, okay.
Because you're not unless you're going to do a 3D print, which I don't want you to do that. Mine is having an issue. Okay, so if you get to Tinkercad, you should look like this, and it should have started you a new one, which is right here. Now, this is similar to what we have done in the past with our other one, except this one's a little bit different because, whoops, sorry, I chose a battery. So over here is where you have your basic components, okay? So we have a pull down screen here where you have your basic, you have your alls, you have your starter basic, and then you have all these different other things. So where we're going to be is we're going to be in the basic components. So if we look, we have what's called a resistor. Remember what a resistor is. A resistor is where it changes the voltage going through, all right? And remember, a light is considered a resistor. We have an LED. We have a push button. We have the pectometer. We have a capacitor, a slide switch. We got a battery. We've got a 3-volt battery. We've got a 1.5 battery. You've got a breadboard that's small, a micro bit, And then you have a DC motor. You have all these things to play with. Okay. So the first thing that I want you to do is I want you to find the breadboard small, and I want you to grab it and pull it out here. Is everybody able to pull a breadboard out?
Yes, ma'am.
I didn't pull mine out far enough. So let's talk about a breadboard first. So this is how a breadboard works. What this is you have your negative line here, and their invisible line that goes from one end to another. Do you see if you hover over the square, you see all of them lit up, don't you? And they're all green. If you move down one, do you see the positive one? It goes all the way down and all of them are green. What that's telling you is if you plug anything in to either one of these, like for example, if I decide I'm going to pull a battery out, okay, and I am going to, and I'm going to have it a 9-volt battery, and say that I'm going to have wires that are going to run to those. So if I took here where it says negative, and I drew a line, and I got to that little hole there, and I let go, what that's going to do is that's going to say, all right, that is a wire. And that wire is taking the negative charge, and anything that's connected to this line right here is all going to be negative because they're all connected together. They have an invisible line. If I take my positive in and I take my line and I put it over here on the positive one, then what that's going to do now is now I have considered a series circuit. So what's happening is my battery is sending voltage into the breadboard, and then is taking the voltage out of the breadboard and bringing it back. Does everybody understand so far? So what I would like you to do is I would like you to go and do exactly what I did. Grab your breadboard out, grab you a 9-volt out, and then wire this breadboard. Is everybody successful?
Yes, ma'am.
Okay. Bailey?
Yes, ma'am.
Cool. Abby, is yours on fire today?
No, ma'am, not today.
Yay. Okay. So
Same here.
what this is this is showing you an information. So you have a positive and negative in here. Okay. You also have a positive and negative down here on this side too. Okay. So you could either use this side of the breadboard or this side of the breadboard. Now, take your cursor and hover over number 1 on the top. What do you see is going on with the line with number 1?
It's going down.
It's going down.
Yeah, it's going from F to J. So that's what that's telling you is if you put anything in this line right here, there is an invisible line that says all of these are connected. Now, does it look like it goes over to E? Is E connected to that group?
No, it doesn't appear so.
No. It connects A through E is connected together too. Okay? So those are the things you have to remember. So let's go ahead and let's get us an LED light. And let's bring him out. I want to change the color of this LED to blue. And I'm going to put this LED light on I1 and 2. Has everybody been successful?
Yes, ma'am.
Okay, cool. So now what I need to do is now I'm going to have to go. And so what's happened is the power is going up through this positive and negative line, but there's an abyss in between that it can't cross. And I need it to cross to be able to get to my LED. Okay, so I'm gonna move my LED down a little bit more so I can have some room. And the only thing I need now is I need to bring these charges to this LED. Okay, so I'm going to go here and I'm going to click this and I'm going to draw me a nice little line going to J1. And I'm going to release it. So go ahead and do that. And so what that's doing is it's taking the wire from the battery, going to this group, going all the way down here, and then it's going to jump that abyss there and get here, which is going to go to my LED light. Okay? Everybody good so far?
Yes, ma'am.
The next thing we're going to do is we're going to go and we got to get our positive because we need a series closed circuit, right? Because right now it's open. So we're going to click this one and we're going to go across and we're going to go to 2 and we're going to let go. Now, what I'm going to do is I'm going to go back in here just so I don't get confused. And I'm going to change the colors that they are. I'm changing black to black.
I did that at first because I was like, those two grades are.
Yep. And red. So I'll know what I'm doing. So this one here is black. And this one here is red. Now, only thing I need to do now is start simulation. Look what happened. I just made a series circuit using a breadboard, lighting an LED light. Were you successful?
Yes, ma'am.
Fantastic. Now, let's go and let's go from basic. Let's go to all. And what I need to find is I need to find something to tell me how much power I'm using. So I'm going to use a multimeter. Okay, so grab your multimeter and pull it on out. Now, if you look at your multimeter, you have A for amps, V for voltage, and R for resistance, okay? When you click your multimeter, it'll give you this screen right here. So what you have to do is you have to figure out what do I want to find. So I'm going to say, let's try and change it to ampere first. And when we do that, do you see it changes it to A? I'm going to go up here and I'm going to use this little button right here, and I'm going to rotate this bad boy so it's kind of facing my breadboard. And so what I did is I just clicked the item, went up here, and rotated it to, I think, where I want it to be. So now what I'm going to do is I'm going to take my line and I'm going to go from the positive one and I'm going to draw me a line right here to maybe about right here because I can actually use it anywhere in here to find out what it is. So there we go. Change that to red. Take my black. You got the black. And now what I'm going to do is I'm going to start my simulation. So right now, what it tells me is I have 6 amps that are running through using this LED light. Now, if I wanted to go and change it to voltage, it says I have 7.63. Well, hold on a second. I have a 9-volt battery. Why is it 763? You know,
Because it loses power over the distance it has to cover.
well, could it have something to do with the powers being used by the LED?
Yeah.
Yeah.
Yeah. Okay. And so then the next one I'm going to do is I'm going to pull it down for resistance. Wait a minute. Why does it have an error?
Because it's not measuring resistance without a resistor, right? Or
Well, you have a resistor right here, but this is the thing. If I break the circuit, now it tells me. But I had to break the circuit because when you're trying to find resistance, you can't do it while it has power on it. It has to be an open circuit to do that with. And so what I'm doing today is I'm just kind of giving you like a little taste of engineering, a little taste of how to use a breadboard. How is it different from electricity a little bit? And I wanted you to have a little bit of a chance to play with this. Now, we're going to do a little bit more tomorrow. And so what's going to happen tomorrow is I'm going to give you some things to draw. So I'm going to give you pictures that you have to redo. And what you're going to have to do is you're going to have to do it in this program and the other one tomorrow. And I think it's going to be fun. I think you're going to enjoy it. And then you're going to actually show the math behind it. And then you're going to use the computer and the simulations to prove that your answer is correct. I know it sounds kind of hard, but it's not. It's fun. I promise. I have kept you a little bit longer than I should have today, so I apologize to that. But I hope that you're going to come away today with, I know a little bit more about circuits. I know series, I know parallel, and I know how to combine them now. I know how to do a FET lab, and I know how to do the new computer system that Miss Sloan showed me today with a breadboard. Jordan, do you have any questions?
I'm all good.
All right, well, you're good. I will see you tomorrow, all right, baby?
Alrighty. You have a good day.
I will. Bailey, any questions?
No, ma'am.
Do you feel confident today?
I do.
Oh, good. I feel confident today too. So we're two confident people.
Yes,
I think Abby feels confident because I'm telling you what, I don't think her thing caught on fire today. So I'm happy. Oh, you listen. You have a good day, baby. Okay.
You too.
All right, Abby. Do you have any questions, baby?
No, ma'am.
Do you feel confident today?
Not 100%, but like 90%.
Well, so you think you're ready for the engineering program at Clemson?
Nope.
All right, baby. I love you. Listen, have a good day, and I'll see you tomorrow. Okay, honey?
Okay.
All right, bye.